Good morning. Let's talk some kinetics calculations. And I'm making a video on each one so that we can kind of have a short video that really describes exactly what I need you to be able to do. So when we're doing kinetics calculations, we have to remember that this has to come from data. And if we don't have data, we can't really do kinetics. And so we're going to have a series of experiments. And so this is experiment, I'm going to call this experiment 1, experiment 2, and experiment 3. You may see them in columns like this or in rows. So if we look at experiment 1, we have two different reactants. And so we need a set of experiments where one is held constant and the other one doubles. So if I compare experiment 2 to experiment 1, so I'm going to take experiment 2 and I'm going to actually divide it by experiment 1. And if I divide experiment 2 by experiment 1, the concentration of H2 will be, that division would be 1. And raised to a power will be still just 1. So I'm only going to concern myself with NO for this calculation. So I'm going to take experiment 2's concentration 0.60 molar divided by 0.30 molar. I'm going to raise that to the M power, and that's going to equal rate from experiment 1, which is from experiment 2, has to go on the top, 1.134 times 10 to the negative 2 divided by 2.835 times 10 to the negative 3. And so this is going to be 2 to the m equals, and don't feel bad about using a calculator for this. Oh, yeah, that's 2. Okay, so 1.134 second EE negative 2 divided by 2.835 second EE negative 3 equals, and I get 4. So M has to equal 2. What we're trying to figure out is the rate expression, which is going to be rate is going to equal K times NO to the M and H2 to the N. So we figured out that M equals 2. I'm going to do the same thing now, but I'm trying to hold NO constant. So if I compare these two experiments, this doubles, but this is held constant. So I'm going to take experiment 3 and divide it by experiment 4. So I'm going to have 0.70 divided by 0.35 raised to the n is going to equal 2.268 times 10 to the negative 2 divided by 1.134 times 10 to the negative 2. And so this is going to be 2 to the n equals, and that looks to me like it's going to be 2. So n must equal 1. So if n equals 1, now I can write my rate expression. It's going to be rate equals K NO squared H2, and you don't have to put in the 1, but there is a 1 there. So that's my rate law. So up here it says determine the rate law, the rate constant, and the orders with respect to each reactant. And this I would ask at this point right now. And I would say the order with respect, so the order for NO is second. Order for H2 is first. And the overall order is 3 or third. So now the next thing I would ask you to do is calculate K. And when we calculate K, we can take any experiment we want, put in the information from that experiment, and calculate out K. So since we have that rate equals K times the concentration of NO squared, concentration of H2, solving for K, I'm going to get rate divided by the concentration of NO squared times concentration of H2 equals K. And I'm going to put in, I think I'll put in the data from experiment 1 here. So it's going to be, the rate for that is 2.835. Oh, can't see that, can you? 835 times 10 to the negative third. And we do care about units here, so this is going to be molar per second divided by 0.30 squared divided by 0.35. And this is molar, and this is molar. So, doing that math, 2.835 second EE negative 3 divided by 0.3 squared divided by 0.35 equals, and I get K equals 0.09. This would be a second zero. So, what are units? So I'm going to take molar per second divided by molar squared times molar. I'm going to put that over 1 so I can flip it. And I get molar per second times 1 over molar squared times molar. So this molar would cancel with that. And I would get as my unit 1 over molar squared times seconds. And so the unit here is going to be, it's going to equal 0.090 1 over molar squared seconds. And that would be what K equals. The only thing this problem does not have would be if I asked you something like, given new concentrations, what is the new rate? And so you would come back here to your rate equation. You'd put in your new values here and here. You'd put in the value you got for K just now, and you'd figure out what your new rate would be. I hope this is helpful, and thanks for listening.